They say the best way to solve a problem is to understand the language it's written in. Well, today we aren't just learning a data structure, we are mastering the art of thinking in characters. Welcome back, everyone. I am Supratim, your coach here at Techmine Guru. Today we are diving deep into string basics. Whether you are preparing for a big interview or just want to write cleaner code and understand how string works under the hood, this is non-negotiable. So here is our roadmap for today. So today we will know what a string really is, right? Then we will unlock the secret numbers behind ASCII. Then we will solve the question of toggle challenge. Then we will master palindromes from basics. And then we will move to boss level, longest palindromic substring. And finally, we will understand what is going under the hood of string memory and what are string immutability. So what is a string? String is a sequence of characters. You can also say string is an array of characters, but you cannot say that string is a collection of characters. Why? Because in string, ordering is important. ACB is not equal to ABC, right? So for the computer, characters are just secret numbers called ASCII. The full form of ASCII is American Standard Code for Information Interchange. So you should memorize these key values there. So capital A, the ASCII for that is 65. The capital Z, the ASCII for that is 90. Similarly, for lowercase a, the ASCII is 97, and lowercase z, the ASCII is 122. So if you want to convert from uppercase a to smaller case a, you just have to add 32. And similarly, if you want to convert from smaller case a to uppercase a, you just have to subtract by minus 32. And this will hold for all the characters. Similarly, for the digits from 0 to 9, the ASCII characters are A48 to 57. Always remember that one character is equal to 1 byte, which is equal to 8 bits, right? Now let's see our first challenge, which is of toggling the case. So suppose you have given a character array and you have to toggle every character from lowercase to uppercase and vice versa. So if the input has given as hello, in which H is capital and rest other are lowercase characters, then uppercase will convert into lowercase h, and all the lowercase ELLO will convert into uppercase ELLO. Similarly, for this input as well, if you see the output, all the uppercases have been converted to lowercase and all the lowercases has been converted to uppercase. So in this question, the input only contains alphabets. So what is the logic? The logic is very simple. You have to iterate a loop from 0 to n-1. You have to check if whether your particular character, which is given by a of I, which is similar to how we handle array elements. So we have to check whether that particular character is uppercase or not. If it is uppercase, then you have to add 32 to make it lowercase. If it is lowercase, if this condition doesn't hold true, that means if it is lowercase, then we have to simply subtract minus 32 to get uppercase character. So the same has been written in the code as well. So we have run a loop from 0 to n-1. We check a particular character of the string is capital or not. If it is capital, we just convert it into small by adding 32. And since we are dealing with ASCII numbers here, we have to typecast it to the character, which will convert it into lowercase character for that element. And similarly, we have to subtract minus 32 if the original character is capital and we want to convert it into smaller. Since we are running only one for loop here, so the time complexity is O of n, and we are not taking any extra space, so the space complexity is O of 1. Now let's move on to what are called substrings. Since we have previously learned from arrays that there are sub-arrays, right? So similarly, for the strings also, we have something called substring. So what are substring? A substring is any contiguous part of a string. So if the string is given as A, B, and C, so what are the valid substrings? A, AB, ABC, B, BC, and C. This is similar to how we deal with sub-arrays in case of arrays. In this, AC is not a valid substring. Why? Because this is not contiguous. So how to find the total number of substrings present in a string? So from the string, we will know the length of the string, and we will simply apply the same formula which we have applied in calculating total number of sub-arrays in case of arrays, which is n into n plus 1 by 2. So for given example ABCD, the length is 4. So if we keep n as 4 in the formula, we will get 4 into 5 by 2, which will give us 10 substrings, right? Now let's see how do we check if a string is palindromic or not. What does the word palindrome means? Palindrome means that it should read the same forward as well as backward. Suppose madam is a word. If you read from back side and if you read from front side, the string will be same, right? Similarly, Nayan is a word in which is like a palindromic word which reads from front side and back side similar. Similarly, we have race car as well. Similarly, we have level as well. So let's see how we can solve this palindromic problem. So for this, we will take 2 pointers, one at the starting and one at the ending, right? Because we know for the palindrome, it should read same from forward as well and same from backward as well. So we will take I as the start and J as the end. And we will simply run a loop from I till one character lesser than J so that we don't end up counting them again. So this is the boundary condition for our code. And here we are checking if these 2 characters in which our ith and jth pointer is pointing, if they are not same, we will return false. And if they are same, we will simply increase the ith pointer and decrease the jth pointer so that I can move forward and j can move backward, right? And if all the characters are matching, we will simply return true. So since we are running one while loop inside this, so the time complexity is O of n and we are not taking any extra space, so the space complexity is O of 1. Now let's see the boss level problem on the same concept. So if we are given the question that we have to find the longest palindromic substring present in a string. So for example, ABACAB is a string and we have to find the longest palindrome. So if you see properly, we have one palindrome as ABA, one palindrome as ACA, but they are of 3 lengths. But if you see closely, we have BACAB as well, which is of length 5. So we have got the longest palindromic substring inside the string, which is of length 5. Similarly, for this example also, we have ACA also as a palindromic substring. We have ABA also as palindromic substring. We have this ACA also, this ABA also, this ACA also, but they all are of length 3. But if we closely look, we have longer palindromic substring than this 3 length. So if you see this, ACA BACAC is the longest palindromic substring present inside the string. Since this A is equal to this A, this C is equal to this C, this A is equal to this A, and B is the common element. So this is the longest palindromic substring present in this string. How to solve this? So let's start with the brute force app, where we need to generate all substrings, right? And we have to check if that substring is a palindrome or not. And if it is a palindrome, we will simply try to count the length. So for getting all the substrings, we will run a loop from I is equal to 0 to n minus 1. And inside that, we will run a loop from j is equal to I to n minus 1. And these 2 for loops will give me the substring from I to j. Now, in this substring, we have to check whether it is a palindromic substring or not. So for that, I have used the isPalin method, which I have written for checking whether the number is palindromic or not. So since we are running 2 loops here, so our time complexity is O of n square, right? And inside each substring, we are checking whether that substring is a palindrome or not, which has the time complexity of O of n. And at the last, this is how we are getting the max length of each substring. Since our substring is from I to j, and if we have the range from I to j, how to count how many number of elements are there? So this is, we have already learned in all our previous classes. This is like b minus a plus 1. That's why the length will be given by j minus I plus 1. And we have to maximize the length so that we get the longest palindrome. That's why I have used this max function, which will tell us whether the answer or the current substring length is maximum or not. So this is the brute force approach. So since the outer 2 loops is giving O n square, and inside that, for checking every substring, we are using isPalin, which is of time complexity O of n. So our total time complexity will be O of n cube. And since we are not taking any extra space, the space complexity is O of n. So what do you think? Can we optimize it? Yes. So for that, we have to simply observe something. So the optimization is to expand around the centers. So if you see properly for this BACAB, so if we have BAAB as the string, so if you see, this is the center, right? And we can expand. Expand means we will move a pointer starting from this as center towards the left and towards the right. And we will keep checking whether while moving forward, we are getting the same characters or not. So first of all, we have to find the center of the longest palindromic substring. And since we don't know what is the center, we have to check all centers. But here a question arises that why we are checking for 2n-1 center. So we will come across this again. Now we can think that why we are checking for 2n-1 centers when we have n characters only. So we will come to this in a short while. Before that, let's understand the expand function. Since we have to run 2 pointers, one backward and one forward. So suppose 2 pointers we have taken as C1 and C2. So we have written the condition C1 should be greater than 0 and C2 should be lesser than n, right? Since C1 is moving this side and C2 is moving this side. And while moving using S of C1, which is like checking whether this character is same as this or not, we will keep moving forward and backward. And for moving backward, we are decreasing the count of C1. And for moving forward, we are increasing the pointer forward. So how do we know whether we are out of the palindromic substring or not? So when the C1 will come here and C2 will come here, and we will know that S of C1 is not equal to S of C2, that means we have reached the palindromic substring. So if you see the range will be C1 plus 1 and C2 minus 1, right? So if we have been given the range of the sub plus 1 to C2 minus 1, so what is the length of the substring? So we will simply keep the formula of counting number of elements from A to B, which is like B minus A plus 1, which is like C2 minus 1 minus of C1 plus 1 plus 1, which will give us the length of the substring as C2 minus C1 minus 1. Then we have to remember that C1 is C1 plus 1 and C2 is C2 minus 1. Since after moving from the loop only, we will come to know that this is not matched. So that's why when we are keeping the same formula into the range, we are getting this one as the length. So this is the expand function. Since we don't know how many centers are there, we have to take all possible centers. So here comes the concept of odd centers versus even centers. So if we have odd length substring, that means we can take C1 and C2 from the same center. So what if we have even length palindromic substring? In that case, we have to take C1 here and C2 here, right? So since we are checking for all the things, in case of odd, we will take C1 is equal to I and 2 is equal to I, which is same. And for even, we will take C1 as I and C2 as I plus 1, right? So for the same, we are writing the code. So for this, we have handled the odd length palindrome case here and the even length palindrome case here. And for odd length palindrome, we are running a loop from I is equal to 0 to n minus 1. But for the even length, we are running the for loop from I is equal to 0 to n minus 2. Why? Because in the even length, we are taking the second pointer as I plus 1. So it will reach earlier to the end of the array. And inside that, we are just using this helper expand function to check whether we are getting the length or not. And every time we are getting the length, we will keep checking whether this is the max length or not, and we will keep storing in the answer variable. And once we are out of this odd length, then we need to check the same for the even length palindrome as well. So where we have taken C1 as I and C2 as I plus 1. And we will call this expand function and we will check the length whether they are giving the maximum or not. And simply we will keep storing the same to get the longest palindromic substring for that particular substring. So since this for loop will give us the time complexity as O of n, this for loop will also give us time complexity as O of n. But inside there, expand function will have its own time complexity of as O of n. So that's why this odd length will give time complexity as O of n square. And similarly for this as well, this expand function will give internally O of n. So this time complexity is also O of n square. So what is the total time complexity? It will be O of n square plus O of n square, which is O of n square only. And since we are again not taking any extra space, so our space complexity is O of 1. So this is a lead code problem for which I have also mentioned the same in our description. You can check that as well. So finally, let's talk about how strings are handled under the hood inside the memory. So since we already know that all the objects are getting stored in the heap, but string objects also keep the value in something called as string common pool. So inside a heap, we have a separate space where string common pool are stored. So whenever you create first time a string, that gets stored into the string common pool. Suppose you have stored hello, so it will get stored here. And every time you want to add any character in that, so it will not get added in that object. It will create a new object and it will keep adding the same. So for the same reason, when you do string concatenation in a loop, so you think that the time complexity is O of n, but it is not, since for every concatenation, it will keep on creating new object again and again. So the time complexity becomes O of n square. So for fixing this, in all the languages like Java, Python, JavaScript, Go, we use something called StringBuilder or string buffer. So StringBuilder internally maintains the same string and keeps on adding the characters which you are adding up in a loop. So you have to keep this golden rule in your mind that every time when you want to append a character in a string, you should use StringBuilder so that it doesn't copy the whole string every time. Now to wrap up today's session, so what we learned today, we learned about ASCII, where we learned that characters are numbers, and also we solved a problem of toggle, right? Then we learned about substrings, that how substrings are contiguous segments of a string only, and how to find the total number of substrings, which is given as n into n plus 1 by 2, which is approximately equal to n square by 2, right? Then we learned what are palindromes and how to check a palindrome using two-pointer technique. Then we learned the boss level problem of how to find the longest palindromic substring in a string, where we optimize the approach using a technique where we expanded from the center, and how we handled their both even and odd cases. And lastly, we learned about how strings are stored inside a memory, because of which they are by default immutable in nature, and how we solve them using StringBuilder. In our next lecture, we will solve some interview problems from LeetCode. So if you found this breakdown helpful, don't forget to hit that subscribe button for more DSA content at Techmine Guru. With this, I am Supratim signing off for today, and I'll see you in the next one. Till then, keep coding, keep optimizing, and keep learning.